A very warm welcome to everyone in this webinar, Trends in OT Security. I would like to remind you that you can feel free to ask any questions in the questions box during the webinar. We will answer these questions by the end of the session. And we would also like to receive your feedback via the survey after the webinar. My name is Remco Huisman. I'm a senior account manager within Secura, within the industrial market group, and I've been working here for 20 years. I'm here today with my colleague Sjoerd Peerlkamp.
Hey, good afternoon. My name is Sjoerd Peerlkamp. I'm heading the industrial market group and would like to present this content today to you.
Two slides about Secura, so you know who we are. We're a digital security expert since 2000, and our mission is to provide insight into your digital security. We would like to do that as much as possible to link it to international standards, metrics, and certification. And we're not only focusing on technology, but also on the people and process side of things. And also important to notice is that we, since at the beginning of last year, Secura is part of Bureau Veritas. Secura is divided into market groups. You're now talking with industrial market group, but we also have market groups for technology, finance, public, and product manufacturers. Within the industrial market group, we deal a lot with operational technology. Well, that's logical because the topic of today is trends in operational technology security. But we're not only dealing with operational technology, also information technology, and when it concerns to industrial 4.0, we also deal with IoT. We offer a wide range of products and services with audit, test, certification, but also behavior things and forensics. Sjoerd, the floor is yours.
Yeah, thank you, Remco, for the introduction. And Remco will also keep an eye on the chat. So whenever you have a question, please feel free to type them in the question box, and we either answer them during the presentation or at the end of the presentation. So the topic for today is about trends in OT security. And to explain a little bit more about that, I would like to start with a kind of principles about operational technology. So a little bit of background, what it is. Then I would like to move into some real-world incident data that we collected and the trends that we can pick from that. Then I would like to explain you a little bit about regulation and standards. That is a hot topic at this point in time. And then I would like to introduce some ways of improving your OT cybersecurity. At the end, I would like to wrap up. So in these 5 steps, I would like to guide you through this webinar. The webinar will take approximately half an hour. With additional time for questions and those kind of things. So we hope to finish 2:45 local time here. To start with the first topic, principles of operational technology security. And I think actually if you're registered for this webinar, that most of you are familiar with the term operational technology. And in short, it's devices that can actually physical things to process physical stuff. So it's hardware and software that detects and causes a change through the direct monitoring and or control of industrial equipment, assets, processes, or events. So just monitoring, changing, switching, those kind of things in practice, I would say. And if you look at this drawing, you can see it here as well. So the core of the core of operational technology is that you're trying to steer something. So in this example, it's a physical process. It's, for example, an hydroelectric plant, and you want to steer the electricity generation of it. So the physical process is utmost important. And in order to have the physical process running in a smooth way, you have all kind of industrial control systems in place, including some engineering workstations, PLCs, RTUs, sensors, and all those kind of things to monitor and steer that process. But always, almost always, I would say, there's always a link to the IT domain as well. Because in the end, you would like to collect data, you would like to steer the processes, etc., based on trends, weather forecast, I don't know what type of information you need. So there's always a link actually between operational technology, IT, as well as the industrial control systems themselves. And where can you find industrial control systems? Almost everywhere, I would say. So from electric power, oil and gas, water manufacturing, towards even defense, aerospace, marine, infrastructure, you name it, probably there is some operational technology in there. To quickly summarize some differences, and there's a very popular way of describing the differences between IT and OT, and that is that in IT, it's all about confidentiality of the data, the integrity of the data, and the availability of the data. And quite often people say, well, confidentiality is less important for OT. It's all about availability and integrity. So it's the CIA triad the other way around. And for me, that's a little bit too simplistic because it's a combination of different networks. And what you see is that especially in the ICS part of the networks, you see that it's all about safety, reliability, and performance. So that's a little bit similar like availability, integrity, and confidentiality, but it really shows that safety is a key priority in there, reliability of the process, and the performance of that process. And for sure, in the OT side, as well as in the IT side, you have the other importance as well. But I think most important to note here, it's about safety and reliability for critical infrastructure. And there are some more differences that many people use in those kind of presentations. So IT is about data, OT is about processes. So there's not a risk for information disclosure, but it's more about health and safety. Technology is most of the times a little bit older, so you don't replace the systems every 3 to 5 years, but maybe up to 20 years. Reboots and process interruptions are actually not accepted, while in IT environments you can install patches, reboot systems, you have your maintenance windows, those kind of things. And I think those are the most important differences in here. And I hope that these are quite familiar to you as an expert in the operational technology as well. And what will the impact then be if something goes wrong here? Why are we talking about operational technology security actually? And the Global Cybersecurity Alliance summarized it in a quite nice way. I say, hey, if cyber attacks can take place on operational technology, it's about endangerment of public or employee safety or health. So things happen in the real physical world. People can get hurt, things can break down, etc. So it's damage to the environment, damage to equipment, loss of product integrity. It's loss of public confidence or company reputation. So if there's no power anymore due to a cyber incident, that's definitely something that will hit the news. If you look back a little bit, in almost every talk about ICS security, you see that they start with describing Stuxnet. And Stuxnet, it was really a watershed moment, demonstrating that cyber physical capabilities were possible actually. So they were able to physically disrupt nuclear enrichment programs by changing the speed of those centrifuges and really damaging the equipment over there. And that was already in 2010, which is more than 12 years ago. And then it took a couple of years before the first publicly known OT reconnaissance activities took place. So you saw the Havex malware that was browsing around, and it was really collecting a lot of information about systems, but not really damaging those systems. And the two most significant attacks were both in Ukraine. And I was quite surprised to see in the past couple of weeks that these similar attacks didn't take place during the Russian and Ukraine war, actually. Because clearly in 2015 and 2016, there were quite some efforts put to destabilize the grid and to actually damage the grid with the Black Energy and Indestroyer malware families. Black Energy was really manual efforts, and Indestroyer was a lot more automated efforts to take down the power grid. And then after 2016 and 2017, Triton and ECANS came there. Triton was really about safety systems, was also known as TRISIS, and had been specifically engineered to target specific type of industrial control system, namely Triconex safety and instrumentation systems, so the SIS controllers, developed by Schneider Electric. And the malware was unusual in the fact that the code hones on those systems to cause process shutdowns and to tamper with emergency systems. So it really tried to trigger unsafe conditions in order that the process would shut down by itself by the safety systems. And then 2020, 21, 22, it's all about ransomware, in my opinion. So you saw the ECANS malware, but you also saw all kind of other malware that is really now also targeting operational technologies. And sometimes they directly target operational technologies like the ECANS malware family. But if you take Colonial Pipeline as an example, actually they attacked the IT systems, but as a precaution and due to, I think, lack of sufficient network separation, they also decided to take their OT systems down to prevent further damage. And also JBS, the meat producer, has been in the news last year. And the beginning of this year, we had the oil terminals in Belgium, Netherlands, and Germany that had to shut down due to ransomware incidents. So ransomware is definitely something that also can harm your operational technology environments. Another nice example that was published recently was about a UPS, and there was actually a vulnerability in the TLS, so the secure communication protocol, and you could, as a hacker, could actually upload malicious firmware to this UPS. And what they actually did is, first of all, they changed the form of the wave in there, and instead of the waveform as a kind of nice sinus, they changed it into a kind of square waveform, which triggered an overvoltage. You can see in here that is now generating 360 volts, and the lamp that is connected to that will blow, and maybe other equipment that you would have connected to your UPS might really be damaged and break down. So that's an example of a cyber physical attack. And by modifying the firmware a little bit further, you even saw that that smoke was coming out of this UPS, and that the full UPS was bricked and couldn't turn on anymore. So this is a clear example recently shown where an IT vulnerability in a communication protocol can really lead to cyber physical damage. You can damage the equipment connected to the UPS, and you can damage the UPS itself. And if you can do these type of attacks, then definitely it will have impact on every device that is connected to these kind of UPSs. So if you look at some trends in here, last year we have produced a white paper, OTCAD, the Operational Technology Cyber Attack Database, and in that white paper we mapped 133 cyber attacks on OT between 1988 and 2021. And what we tried to do there is map them against the attack vectors used in the Marja attack and the Marja attack for ICS frameworks. We map them towards industry domains, and we map them against adversary classifications. And it's all open source. So if you want to browse through it, if you want to read the analysis, those kind of things, you can find everything on our GitHub page or on the secura.com/whitepapers/OTCAD page. And we really wanted to have high level of credibility in here. So we only wanted to have publicly accessible information in there so that everybody should be able to confirm the content of these incidents and those mappings. And furthermore, we wanted to base it only on factual information. So it's no speculative mapping, only real facts that could be verified. And we really hope that we can grow this collection through collaboration. And currently we are in discussion with the National Cybersecurity Center in the Netherlands, whether they can also support this initiative to keep the database up to date. And the idea is that you can see all kinds of trends in it. For example, in this graph, you see the blue line, so the upper line, about targeted attacks. And you see that in the past couple of years, since 2012, the targeted attacks are really taking more place than the non-targeted attacks. The orange line is about disgruntled employees. The gray line is about untargeted attacks, so I would say collateral damage. And the yellow line was unknown attacks. So sometimes this type of information is not available. And this is, for example, the type of information that is available in the white paper. What we also did is kind of mapping against different sectors. So you see that power and utilities and transportation had the most attacks actually, while other sectors were a little bit lower, like food and beverages 2, pulp and paper 1, etc., in our data set. And we could also zoom a little bit into the type of initial access that attackers got. So how did they manage to get access? And the blue part on the bottom here is engineering workstation compromise. So you saw that especially in the beginning, almost all attacks took place via taking over an engineering workstation and from there doing all kinds of harm. But the orange one, you can see it in here. Let me see. The orange part here is about spear phishing. And you see that the last couple of years, the spear phishing really took a rise in here. So quite a lot of attacks start with a kind of spear phishing attack nowadays. Furthermore, the other one to mention is exploit public-facing applications. So that's the gray bar that you see over there. And we have some other attack methods mapped as well. So if you want to learn more, we did a separate webinar specifically on this operational technology cyber attack database. You can also read the white paper, and I think it's interesting to read these kind of trends to make sure that you take the appropriate measures. And Secura also uses the kind of incident statistics in order to classify risk and prioritize risks in our quantitative risk analysis method that we use. If you then move forward towards latest trends in regulation and standards, you see that this is definitely a topic that popped up the last couple of years. So in 2019, you saw the adoption of the EU Cybersecurity Act, where ENISA was appointed and mandated as the cybersecurity certification framework and coordination of C-certs. And you also saw that the NIS Directive came up. The NIS 2 actually is now up for approval. You see that a lot of certification frameworks came there, like the Radio Equipment Directive, reinforcing coverage for cybersecurity. You saw the medical device regulation that also included some cybersecurity requirements, and all kind of areas you saw that cybersecurity for operational technology really got in focus. And you also saw that in industry standards and frameworks. And for example, for car manufacturers, the EU and ECE, that's UN Working Group 929, has released 2 regulations for cybersecurity in automotive industry. And that really helps in making cars more secure. NIST came with the NIST Cybersecurity Framework, a kind of model with 5 pillars. We'll come back to that later on a little bit, how you could assess cybersecurity in organizations. For sure, the last couple of years, the IEC 62443, which is an international standard, also became the de facto standard actually for operational technology. It is a series of standards set up by the International Society of Automation, the ISA, and it has a lot of useful information in there, how to separate networks, what measures to take, how to get in control of your cybersecurity. And you saw that IEC 62443 was also the basis, once again, for all kinds of other regulations and standards. So for example, in the rail, last year they announced the TS 50701, which is a standard specifically for rail, but which is heavily based on the IEC 62443. So this is the example for rail, released July 2021. We also have an example for the network code on cybersecurity, which is actually an initiative by ENTSO-E for the grid operators across Europe. And for sure, we also have the NIS Directive. And I think the NIS Directive really made an impact to operators of essential services. They all of a sudden had to prove that they took appropriate measures to protect their operational technology. And they also had a report. It was also mandatory to report potential incidents actually to the regulator, as well as the national security emergency response teams. And the NIS Directive actually has 3 important parts in there. So it's about national capabilities. So EU member states must have a certain national cybersecurity capability of the individual EU country. So every country has to have a body that is coordinating these kind of initiatives. Furthermore, it arranges cross-border collaboration. So all those local country bodies work together, share information across EU. But the third part is most important in here, is national supervision of critical sectors. So all those member states have to supervise the cybersecurity of the critical market operators in their country. Energy, transport, water, health, etc., etc., etc. So if you're part of critical infrastructure here, you have to prove actually to the regulator that you take appropriate measures. So the NIS Directive really has a big impact, and also the next version, NIS 2, will be released soon and needs to be implemented by every member country. And the NIS Directive is really about risk assessments. So it requires companies to do risk assessments that cover all operations, including the security and the resilience of network and information systems. So the idea is that you understand the impact of cybersecurity on your operational processes and how harmful that would be for your processes. And it also tries to promote a culture of risk management, actually, to make sure that whatever you do, you take the right decisions based on real risks. So if you look at Article 18 of the NIS 2, the next version of the NIS Directive, you see that they mention 7 key areas in here. The first one is about risk analysis and information system security policies. So it's about risk management, how you do that. It's about the policies and those kind of things. The second part is about incident handling. So that now got really into focus, that if something goes wrong, how are you going to handle it? And that's also related to business continuity, of course. Can you still maintain operation if your operation and technology is hit by a cyber attack? The next part is also a hot topic in the last 2 years, I would say. Supply chain security. Many companies are dependent on vendors to do remote access, maintenance of equipment. They even buy systems that are fully supported and maintained by the vendor. So if you don't get control about cybersecurity of those kind of vendors, you still have significant risks in your own organization. So supply chain security is made a separate topic now in the NIS 2 standard. Furthermore, it covers security and acquisition, development, and maintenance. So if you take over other companies, if you acquire all kind of things, that's also part and something that needs to be inspected and where risk assessments need to take place. The before last part is about policies and procedures to assess the effectiveness of cybersecurity risk management measures. So how effective is your system actually? And the last one is, in my opinion, a little bit strange to have it as a separate topic, is about cryptography and encryption. So these are the 7 main topics that are covered by the NIS 2 actually. So now you ask maybe, what's the difference between the NIS 2 and the NIS 1? We try to identify a few main differences here. For example, new sectors of industries are covered, and I will cover them on the next slide actually. And in the past, they had a difference between operators of essential services and digital service providers, and that difference is now gone actually. So now, instead of having the difference between operators of essential service and digital service providers, they now have essential services like energy and transportation, and important services like waste management, postal and courier service, and these kind of things. I will cover them on the next slide. Another difference is that suppliers with no base of operation within the EU can fall under the scope of the application of this directive, which is also new. So if they supply stuff that is used in the EU, they also fall under this regulation actually. And also the sanctions are rising actually. So it's now GDPR level, like I would say, topping at a 10 million or 2% turnover, whichever is higher. If you look at the sectors, essential services, energy, transportation, banking, financial markets, health, drink and wastewater, digital infrastructure, public administration, and space are defined as essential. Under the important category, they say postal and courier services, waste management, manufacture, production, and distribution of chemicals, food production, processing and distribution, manufacturing, and digital providers. And I think that specifically food production and logistics is quite some new important sectors that require some attention in the upcoming years. So if you would like to improve your cybersecurity, where do you actually start? In my opinion, you really need to use the standards already available. So on the strategic level, I would say use a cybersecurity management system based on ICS 62443. It clearly describes how you can manage your cybersecurity on the next slides. More on the technical level, I would say use the NIST cybersecurity framework. It has 5 very nice pillars. The first pillar is about identify, which means do you have insight in all the equipment that you have? How do you do risk management on the equipment, and so on and so on. The second pillar is about protect. How do you protect those systems? The third and the fourth pillar are about detect and response. So if an attack takes place, are you able to detect it, and are you able to respond it in a well manner? And the last part is about recover. Do you plan for disaster, and how can you recover quickly from that? So although you can use the measures from the ISO 27000 or the IEC 62443, mapping them towards these 5 pillars really helps in also providing kind of dashboards about where are you doing good, where are you less effective with your security measures. And more on the operational level, I would say use MITRE ATT&CK and the ATT&CK for ICS frameworks. It's really a nice collection of all kind of techniques and procedures used by attackers, and you can map them easily against your defenses and see how effective that is. So if you look more at the strategic level, the cybersecurity management system, the IEC 62443 describes actually 6 main elements in here. So the first one is about initiating the CSMS, so the cybersecurity management system. It will make sure, it will provide the information that is required to get support from the management actor. And then it goes into high-level risk assessments. So what are the core processes? What is the risk linked to that? And how important are those assets for you as an organization? If you have a clear visibility about the core process and those kind of things, it goes into detailed risk assessments. So what are the vulnerabilities that exist in those key components and how important is that for you? Then it goes, the fourth topic, about establishing security organization and awareness policies. So what's your way of working? How do you describe that, etc., in a uniform way? After the policies, it goes to countermeasures, actually. So what are the measures that you want to take to protect against the threats that you identified earlier? And the last part is also, how do you maintain a CSMS to ensure that the CSMS remains effective, actually, and supports the organization goals? So these 6 components are described by the IEC 62443 on how to implement a CSMS program. And it has a lot of details in it and a lot of guidance on how you can do that in a very good way. And for the ones who don't know, the IEC 62443 actually has a lot of standard documents below it. So it's divided into 4 different layers, I would say. It starts with more a generic layer that describes the concepts and the models in the -1-1. It's the master glossary of terms and abbreviations, the system security conformance metrics, all these kind of things. It's more general terms and conditions, I would say. Then one level deeper, it goes into policies and procedures. So the -2-1 is really the requirements for industrial control system security management system. So that's the CSMS that I just talked about. The -2-2 is the implementation guidance for the security management system. So it really helps you in implementing this guidance. If you go one level deeper again, it's about the system. So it describes in 3 different parts the security technologies for industrial control systems, security risk assessment and system design, and it describes system security requirements and security levels, actually. And I think the -3 is also one of the most important parts here in this standards, because it really describes how you can select the right security levels for all your components. And if you go one level deeper even, it's about the component level. So the -4-1 and the -4-2 really describe the product development requirements and the technical security requirements for those components. And you see that I draw some orange boxes around it. This is stuff that we can technically test in penetration testing or security testing. And you also see that I draw some blue boxes around it. And that part is about the process that we can also audit, like ISO 27K is really about the processes that you have in place in your company. So the combination of all those documents is really helpful to organize your cybersecurity in the operational technology environment. If I zoom then a little bit into the risk assessments and the outcome of those, what you see here is that based on this risk assessment, you can see the security levels of every component. And the idea is that based on the risk, you separate all those components into different zones and conduits. And you determine for every part, you determine the target security level, the SLT from target. And there are 4 different security levels already predefined in the standard here. And 1 is to protect against every script kiddie, I would say. And 4 is really nation state skilled hackers that really have specific skills and high motivation to hack you. And depending on your risk level and depending on your target security level, you take different measures. So what you can see in here is that if as an attacker with a high capability and a high intent to hit you, you end up into the SL4, which means that there is more strict security measures actually. And it can be technical, administrative, physical, etc., etc., etc. But it's a very nice way to do risk assessment and to select the appropriate security measures. So if I would like to come to conclusions for today, I would say we see that the attacks are increasing in sophistication and volume. And if you want to learn more about the details there, please follow the OTCAD webinar that is also available for rewatch. It has been a couple of months before that we talked about that. Attackers are also increasingly targeting OT assets, also for extortion, including ransomware and those kind of things. But you can imagine that if an attacker can threaten you to shut down power, if the attacker can threaten you to disrupt your primary business processes, I would say, then it has very good reason to ask for some ransom. So it's not only about encrypting your data anymore, it's really about threatening to either damage equipment or to shut down your primary processes. And I expect that more incidents will follow there actually in the upcoming year. We also saw that more and more regulation and standards come, which is very helpful. And that included the NIS Directive, the ICS 62443, but also the specific standards and regulations per sector, like the Network Code for Cybersecurity in the grid operators and the Rail Security Standard. So if you would like to move forward, it's really up to you to get in control of cybersecurity. And in order to do that, start with a CSMS, Cybersecurity Management System. For example, based on the ICS 62443 described CSMS. If you have that management system in place, make sure that you do your high level and detailed level risk assessments, because that means that you protect what matters most. You can't protect everything. You really need to bring focus to those parts of the equipment that are really important for your business processes in there. The next thing you need to do, and it's also really something that is a trend right now, is that you need to develop effective incident response plans and practice them. You can do that in tabletop exercises, but also in operational technology red or purple teaming, which means that we actually simulate an attack and that we really try to mimic real world attacks and try to hack you. And in that case, you test the full chain of the NIS cybersecurity framework. We see how well your system is protected, but we also test your detect and response capabilities and your business continuity planning actually to see if you could actually manage such a crisis. Another thing that we see that many companies are doing currently is implement anomaly-based security monitoring. Think about products from Clarity, Nozomi, Forescout, Darktrace, and so on. So that, yes, we know that it's hard to protect those kind of systems. They use insecure protocols. They're insecure by design, but at least monitor if hacking attempts are ongoing and respond to those kind of monitoring alerts. Another trend is really third parties and supply chain. I mentioned it earlier in this webinar. This is definitely a topic that is top on the agenda of many of the companies right now. And last but not least, please keep the Purdue model intact while supporting new IT/OT innovations like cloud, blockchain, artificial intelligence, etc., etc. So what you see is that the IEC 62443 really has a nice Purdue model which describes the zones and the conduits and those kind of things. But many new innovations cross the borders of all those zones and like to interlink everything with everything, and that is really harmful for, I would say, one of the most effective measures, network zoning. So make sure that whatever you do with your new innovations don't hurt the Purdue model, which you have carefully been implementing the last couple of years. That's it for today. Please make sure that you write some questions in the question and answers box so that we can answer them. We will also have 2 additional webinars in the upcoming weeks. One is more about the cybersecurity of industrial equipment based on the IEC 62443, which is 29th of March. And we also have a webinar about raising resilience against ransomware, which will be 12th of April. Furthermore, I would like to remind you once again to fill in the survey. As soon as we close this webinar, you will get a box with the survey in there. Please fill it out. It's very helpful for us. And now I would like to open the floor for the questions and answers.
Okay, thank you very much, Sjoerd. Yeah, we got some questions coming in. One is, has Secura ever rendered certification services according to IEC 62443 for offshore wind farms?
Good question. I have to ask with some colleagues. Actually, we do security certification based on IEC 62443, also based on components and those kind of things. And one of the cases that we often use there is the Hitachi ABB, where we certify many of their equipments. I'm not sure if you have specific examples actually for offshore wind. I think so, yes, but I need to confirm that. So if you leave your details in the survey or in the chat, then we will follow up with you.
Yeah, thanks, Sjoerd. I do know that we have pen tested offshore wind farms in the past, and with quite some interesting results.
Yes.
But that's something else than certifying it. But it would also always be part of it. So we have experience there. Another question that came in is, could we prove NIS 2 compliance by being certified against, for example, ISO 27K or IEC 62443?
Yes, that might be helpful, but the NIS 2 requires more. It's also about reporting incidents and those kind of things. So ISO 27K and IEC 62443 are definitely a good step to prove that you're in control of cybersecurity and that you take appropriate measures with your risk assessment and those kind of things. But there's more to be done than that alone.
Okay. Another question. Do you perhaps know when the NIS 2 directive will be effective? How much time?
Yeah, that depends a little bit on the local implementations in every country. So I think they now agreed all on the scope and on the content of the documentation, and then the member countries have around, I think, 18 months or something like that to actually implement it. So it will be in the next 1 to 2 years actually before it will become effective.
Yeah, does Secura, another question about services that Secura could provide to guide companies to comply to NIS 2?
Yes, definitely. So we can do a kind of gap analysis where we see your current security processes and measures, and we map them against the minimum set that you should have in place to prove NIS compliance. So ENISA has a very nice framework that covers all the topics that you need to address when you would like to become NIS compliant. But I must say, NIS is not something you can certify against. So it's definitely something that you need to prove to your regulator that you take appropriate measures and those kind of things, but it's not a fixed set of measures that you need to implement. So it's all about appropriate measures, and those risk assessments and those kind of activities really help to show to your regulator that the appropriate measures are taken.
Okay. And another question about NIS 2 is, do you know what the difference is between essential and important operators with respect to regulations and implementations of measures? Is there a difference?
Yeah. So that's fully described in the standard, and it's maybe too much for this webinar. But there's quite a nice text around it, which justifies the separation in these two categories. And for the first part, let me see if I can get the slides here quickly. So you see that for essential services like energy and transport, there are more strict requirements than for the important services, and they also specify the differences in there. So it's fully written out there.
Okay. Yeah, and if I'm not mistaken, Sjoerd, I think in the beginning of July we will start a series on webinars on NIS 2, right?
Exactly. So the dates need to be confirmed, but we definitely want to give more content about the NIS 2 directive, because this will be one of the most significant regulations in the upcoming years.
Okay. I have no more further questions. So if there is not any questions coming in within 10 seconds or so, I think we can conclude this webinar for now. Please, that was what I wanted to say. Please fill out the survey so we can learn more about how you experience this webinar and what we can improve in the future.
Thank you very much. Any remaining questions, feel free to reach out to either Remco or myself. And with that, we will close this webinar.
Thank you very much. Goodbye.